All right, let's talk about ratio and proportion. Ratios, first of all, and that's what this video is going to cover, are basically just a comparison of two numbers. Basically, think about a fraction. A ratio is just to compare, or using division to compare two different quantities here. So there's three ways to write ratios. You'll notice in that box in the upper right here, we've got fractions. We can write them with a colon here, right? Or down below, and as we sort of talk our way through a ratio, what we can usually write is it's a ratio of A to B. Again, same thing as if it's a fraction, it's a ratio of A to B or A to B with that colon. So when we talk about ratios, we want to talk about reducing them. So we can just write a ratio. So notice down here in the gray box, we've got 12 to 9. So we have a ratio written, but we want to reduce that ratio. And again, that's where writing it as a fraction is often very helpful because we're used to reducing fractions. So if we rewrote that ratio as a ratio of 12 to 9, well, remember that that's really the same thing as 4 times 3 divided by 3 times 3. And in that case, remember when you're multiplying on the top and on the bottom, you can obviously divide things away. So again, that 3 can be divided away. And therefore, 12 to 9 is really the same thing as the ratio of 4 to 3. And that would be a much better reduced ratio. And again, you could rewrite it again back as, a verbal statement or using a semicolon or a colon right over here. But again, I'm just going to leave that in fractional form. Same thing goes for 15 to 25. Let's take a look at that one. Again, there's a 5 in both of those numbers. So again, if you rewrote that as 5 times 3 over 5 times 5, those first two 5s, again, are going to just disappear. And basically, we end up with 3/5. Right? And again, you can leave that as a fraction, or if you really wanted to rewrite it back how it was written originally, we would just say 3 to 5 there. Now, down at the bottom is a couple of ratios that we can take advantage of. A lot of times we compare the size of two different things. Again, that's the whole idea of a ratio. It's a rate. You're sort of comparing two things. Find the ratio of the 9th graders to the 10th graders. Well, at a fundraiser, again, 18 9th graders, 14 10th graders were working the first shift. Well, the ratio of 9th to 10th graders, well, there were 18 9th graders. So very simply, I'm going to start off saying 18 to 14 10th graders. And then, of course, I want to reduce that down. There's a 2 that goes into both. They're both even. So that would be a ratio of 9 to 7. Right? So there is our ratio right there. And again, we can do the same thing with the ratio of 9th graders to all students. Well, again, there were 18 9th graders. And now I'll have to figure out how many students there were in total. They didn't tell us that. So let's just put all the students, 18 plus 14, down here. Now remember, we can't divide those 18s. It's very tempting. But because we're adding on the bottom, remember, I can never divide away things that are added. Only like we did up top here, can we divide things when they're multiplied, right? Over there. So I need to figure out what that number is. But again, that's not tough to do. 18 plus 14 is going to be 32. And now I would want to think, okay, they're both even again. So I could definitely say 9 to 16. And now those two numbers don't have anything in common, right? And only 3's go into 9. And 3's aren't going to go into 16. So therefore, there is our ratio. I hope that helps you talking about ratios. We'll talk about proportions here in the next video, so make sure you watch. Otherwise, if you have any questions, talk to your teacher, and have a great day.